Okay. All right, welcome to the stream. This is the first time I've streamed on YouTube, so I'm not quite sure what I'm doing. Don't quite know how to give the stream a name or anything like that. I might have to just name it later. Anyway, the point of this live stream is just to build a Max patch using Claude Code. So this is using a new Claude Code system or framework, I guess I should call it, that is designed for using Max MSP. So it's here on my GitHub. We see Max MSP Claude Code framework, and open it up, and we can see that it's free and open to use. I'd love for other people to start experimenting with it and try to build some stuff and send me feedback and create GitHub issues and iterate on this. And it can also be installed as a npx using a command line. So the whole thing is designed to work with Claude Code, and Claude Code is excellent at things like JavaScript, C#, C++, to a certain extent, code blocks within Max. So, programming languages essentially, and it's not so good at user interface. It's not so good at the kind of visual programming of Max MSP. And so that's kind of the goal of this framework, to make it work. And so I'm not going to go over how to use it precisely today. It's all in the README. Instead, I'm just going to try to build something with it and see where we can get. And maybe while Claude Code is thinking and working on it, then we can have a look at the README to see how things are done. So we'll just start with the very first kickoff of the max new command. So what this repo introduces is a number of slash commands that are slash max and then hyphen whatever. So we're going to do max new, and we're going to try to make something that is going to rely pretty heavily on gen, I think, but then integrate it with a help file as well. And so I think we'll try to do time stretch. So we'll just call it max new time stretch. Hit enter. So now Claude Code is going to think for a second, and it's going to create a new directory. It's going to create a new context markdown file. And then we are going to engage in a discussion, or rather these three steps to get it going. So I'd like to make this a little bit larger. Let's zoom in. Let's zoom in again. Good. Okay, so the project time stretch is now active, which means that this instance of Claude Code is focusing on this new time stretch project. So there are other Max projects that I've already built using this, but presently the focus is on this new time stretch. So project time stretch is created and active. You can open it here in Max now. What is the audio source? What kind of time stretching? What controls do you need? Any specific requirements? So let's go one by one. And we can also kind of ignore this and take this in a different direction if we want to sort of give it a broader context without these specific questions, or maybe adding more. But let's use these. So for A, I would like it to be both with live audio input as well as preloaded audio file in a buffer. So that one's easy. A, both. Or I should say 3, both, but it would understand anyway. For B, what kind of time stretching? Granular, overlapping grains, phase vocoder, simple vary speed, multiple modes. I want to go for the granular approach. And I would like you to perform research on time stretch algorithms, both in terms of commercial, open source, and implementations described in academic literature to build the time stretch in Gen in the most flexible and high quality way possible. C. What controls do you need? Just stretch ratio, grain size, full UI with waveform display, position, playback position, preset recall, something else. Let's go all out. Let's do full UI, waveform display, playback position, preset recall, because that will test some of the things that Claude is not as good at, namely UI. D, any specific requirements? Real-time continuous input stretching, offline triggered stretch a loaded buffer on demand, MIDI triggered playback, sync to tempo transport. I think well, real time is already covered. I think both 1 and 2 are kind of the ones that I'm interested in. Stretch a loaded buffer on demand is, yeah, it would be useful as well. The other two perhaps later, but for now I think 1 and 2 are what we need. Great, so it may be thinking for a minute now, and it's building this markdown file called context. Excuse me. Great, and we can see the context there. And it's good to, it can be interesting to look at these to see how your responses have been interpreted, and try to see where there may be a gap between what you want and what it has understood. It's also a good place to catch where it might be lazy. Sometimes Cloud Code seems to go for kind of like lazy solutions, like sort of good enough things, and I'm not quite sure how to deal with that best, but it seems like the type of language you use, and also sometimes the implementation of like agent teams that are critical. So different Claude agents will be sort of critical of one another to catch these things, and that's built into the system somewhat, but I'm always looking for ways to improve the system. Okay, got it. Launching deep research. Okay, so now it's doing the research. So it's launched 3 agents here: commercial implementations, open source code bases, and academic literature. And we can see it's listed the ones it's already sort of identified and focused on. Some of these I've heard of, some of these I haven't. I know, yeah, interesting. Academic literature. Great, yeah. So the window functions will be maybe an important one here. I'll synthesize all 3 into a unified research document and implementation strategy once I complete. This will take a few minutes. Yeah, so the research can take some time, and it will continue on once all 3 are completed. In the meantime, we can look at this. So we did the kickoff. We did the discuss. It was a rather short discussion, but admittedly, it's a pretty straightforward idea. I just want to create a high quality time stretch using Gen. And now the research. Actually, I'm not even sure. It looks like it's doing external research, because then there will also be research into what in Max is best to use to implement it. So once this all comes together and it's ready to build, the max build command is what comes into play. So this is all kind of like a setup of the project, and then the building actually happens here. And I've had mixed results in terms of the first build, but only sort of one of the patches I've made so far has come out where it's basically done and perfect on the first attempt. And that was actually with a stutter effect, which I was surprised because it was actually kind of a complex thing with a complex UI. But it just, for whatever reason, it pulled it off the first try. But often it'll be a mess the first try. And so then your options are to iterate. So you use max iterate, and then you can also sort of include more discussion and research, or ask it to have a really kind of complete consideration of what you're asking it to iterate on, or a simple iterate. But these are to make sort of incremental improvements. So say you open up a patch and there's all the parameters are connected to a subpatcher, and inside the subpatcher, none of those inlets are actually attached to anything, or there are a bunch of errors in the Max console. Here's where you can use max iterate to say, these aren't connected, here are the errors, and it will fix it up. And so if something is kind of close, I'll use max iterate. And only once have I said to Claude, what you've done is so riddled with mistakes. We should identify why those mistakes happened, improve the system so that those mistakes don't happen again, and then we will try to build again from scratch using the same context. And that worked actually quite well. So we'll see if we need to do that. Okay, so research commercial time stretch is completed. Commercial research is back. Excellent depth on blah, blah, blah. Okay, so we can actually, if we like, we can look in at these results. So here you can see all the different patches that I've generated. And so our new one is time stretch here. And we could look at, I guess research will be somewhere else. We could look at our context. So it's quite simple. There's a versions.json. So here we have 0.0.0, and keeping track of the status there. So that's all part of the repository. And then in generated, you'll actually find the patch, but there's nothing actually built yet. It's just initiated a blank patch. But let's go back here. Maybe we can find the research document. Interesting. I wonder actually where that's kept. Oh, there we go. So you can see I've made it so you can see the blank, not blank, the hidden files. But here, if we go into planning, which would normally be a hidden file, and in research, okay, this isn't the research for a specific project. This is more the research for the system itself. Patterns, it wouldn't be there. Source, interesting. All right, let me ask it. By the way, where in the file structure are these research documents? The research runs in memory and return the results directly to conversation. There we go. Once the third agent, I'll synthesize into a single research document and write it to patches, time stretch, context. Interesting. That's the project canonical context file where all research decisions and specs live. Okay, so it'll go into the context markdown file once it's all completed. Great. Open source research is complete. Good, so we're just waiting on one more. Just while we're waiting, some information maybe about the system itself. So the way it works is in this initial creation of a new patch, it will actually build it using Python scripts. But once the initial build has happened, it will discard those. So that, and after that, it will work directly with the max patch. I believe it's like JSON, essentially, files, so that human edits and patch generation will not conflict. So one thing in the first version of this system, it was always, instead of updating the patch directly, it would update the Python file, which would then generate the patch anew. And it was interesting, but it meant that you couldn't manually edit things in the patch without them being overwritten upon the new generation of a patch. So this was a major limitation, because I don't want Claude to just create the patches and not be able to, it's often like a modular approach, right? I'll get it to create like an EQ or this time stretch in Gen, but I want to be able to make it look different, integrate it into different patches, iterate on it, and also, sometimes it really struggles with certain functionality, and maybe there's a better way that I know how to do it, right? So at presently, it's not at the point where you can use it without understanding at least the basics of MaxMSP. And if you are, a more intermediate or advanced user of MaxMSP, it's actually much easier to build, because it's easy to identify where it went wrong, right? Like if I open it up and I see that the messages to a line tilde object are formatted all strange, then I can tell it what it's done wrong, and then it can update the system. It can update the database of information about Max objects that it understands, and it can fix the problem. All right, so here we have research synthesis is written to patches time stretch context.md. Here's a summary. Algorithm WSOLA enhanced granular OLA in Gen. The sweet spot for a Gen implementation, better than naive granular, achievable without full phase vocoder complexity. 8 parallel grain voices with hand windows at 75% overlap. WSOLA cross correlation search at each grain launch to find optimal phase alignment. This is the single biggest quality win over basic OLA. Okay, that's interesting. Transient adaptive grain sizing. Envelope follower detects transients, shrinks grains from 40 milliseconds to 10 milliseconds to preserve attacks. Ah, that's great. So whenever I've built granular stuff in the past, I've not taken some of these approaches, even though they're now over 20 years old. So yeah, this is quite interesting for me to understand. Quasi-synchronous emission with 5% jitter to eliminate periodic buzzing artifacts. Okay, interesting. It's a classic issue with time stretch. Independent pitch control via grain playback speed. Okay, that's interesting. I will probably ask it instead to do this with sense, 100th of a semitone, rather than with semitones. Circular data buffer for real-time mode, external buffer for file mode, great. Pulse stretch style extreme mode, large grains with randomized positions for, okay, yeah, great. I don't know if that last one's necessary, but sure. Key findings from the survey: WSOLA matches phase vocoder quality at moderate ratios per Dreiger and Mueller 2016. Phase vocoders only clearly win at extreme ratios, where we add the randomization mode anyway. Ready to build. The project is fully research designed. Run max build with something like WSOLA and his okay. Should the build / command be more detailed or refer to the context markdown file? The context is everything. The build agent reads it automatically as part of the project context. A short description is fine. The agent will pull the parameter tables. Okay, great. One small change first. The pitch control should be in sense. I'm sure it would understand, but 100ths of a semitone rather than semitones. Great. Yeah, dial in semitones, dial in sense. You know what? For the sake of certainty, let's actually open up this. No, not that one. Time stretch. Let's open up this context markdown file. I'll make it bigger. Hold on. Oh, how do you... Oh, I can't zoom without opening it. All right, let me open this in here. No, hold on. That's what I want to do. All right, please open the context.md file. Great. Okay. Audio source with live. Okay, so those are just direct questions. Signal flow, live input buffer to grain engine to output, stretch ratio, grain size, window shape to randomization, key design decisions, gen, buffer, overlap add with configured grain count, waveform. I'm curious how it will detect the transients in order to have this changeable waveform. Algorithm instruction to okay. After surveying commercial, okay, we read that. Ableton's best modes are phase vocoders, not granular. The granular modes are creative tools. Okay, sure. From open source code bases, Super Collider, WSOLA, from academic. So phase vocoder may end up being the better approach, but let's try this and see what we can come up with. I mean, certainly there'll be some editability improvements here. Over when using grains. Quality tiers, standard, high, extreme. UI design, stretch mode, grain size. Dial with adaptive mode toggle. All right. I'm curious about how the adaptive mode will work, so I'm actually going to ask. The context mentions a grain size adaptive mode. How does this work? Luckily, Claude doesn't mind my ample typos. From the research, adaptive grain size works like this. Transient detection arrives. The envelope follower tracks the input signal with fast attack and slow decay. When the envelope rises sharply, exceeds the transient sensitivity. Okay, so it got a transient detector, simple transient detector built in. Transient sensitive. Okay. Interesting. History for state campaign. Okay. Should there be any research into transient detection before we build? Good instinct, but I think we have enough. Inside Gen code box, we're limited to time domain approaches, which narrows it down to a few well understood options. Well, it could be done outside of Gen, I suppose. Amplitude, envelope fall under, fast attack, simplest, slew rate, band split envelope, high pass filter before envelope fall under. Right, okay. Yeah, that seems fine. Okay, great. Please write out a complete build command so I can paste it into a new context window. So yeah, so you see here at the bottom, it's even though it's a max 1 million context, I think it's like a token count thing, and I'm only at 8%, it's still good to start with fresh context modes as much as possible. And so that's one of the reasons for creating this system in general, is to manage the context windows. So you do all these things, you boil it down to this context markdown file, and then you can refer to that. And so you can always sort of be working with fresh context windows. See, I wrote a nice long one there now, so let's use that. So in order to do that, I'm going to clear the conversation history and set up a free up the context, and then paste in the build command. And now it will generate the patch. So this, this isn't such a complex task, I think, so it shouldn't take too long. One thing that we didn't specify was what we want it to look like outside of the basically just the time stretch algorithm in Gen itself, right? It did mention a UI around it, but we weren't very specific about that. So like it might have made sense to say something like, create one max patch that can be easily used as an abstraction with inlets and outlets that have that have been descriptions in the inlets and outlets to easily use in other patches, and then create a help file for it as an abstraction that has where you can test it out essentially. But we could always do that with a max iterate, or if it's a big mess when it's finished building, we can try expanding the context and building again. So yeah, I'm not quite sure how long this will take. It's been pretty variable. But in the meantime, I can go back to this. So we did the max build. The router analyzes your request, dispatches the appropriate agents, and directly writes a new max patch file. Output lands in patches, mysynth generated. Right, there's a /scan to onboard an existing patch. So I find that this has actually worked pretty well. One limitation right now, though, is that it's all vanilla max. I even have to kind of ask it very explicitly to use things like live.scope rather than just scope. And so that's definitely a room for future improvement, is to integrate all the things that are available in Max, and especially like some of the packages that are out there. Like I'm a heavy Flacoma user, but there are lots of great Max patches and packages, and so integrating those into the database so that they can be accessed, I think would be a good next step. And so when I onboarded a patch that used ML star library, Ben Smith's library, as well as, or I should say package, as well as Flacoma quite heavily. And so it did understand what was happening in the patch, but I don't think it could fully sort of iterate on or build upon that patch without first expanding to understand those third-party objects. Max test. So yeah, this is interesting. I mean, it runs this as part of the build process and iterate process, where it kind of runs tests to make sure the signal flow is correct and what have you. I've yet to actually try it on its own. It would be interesting. And max iterate we already talked about. And you have the flags for max iterate that can be quite useful. So full will run discuss, research, and plan, but then you can also isolate, like, I want to discuss what I've described in my iterate before actually building. I want you to do research. I want you to do planning mode that will be approved before executing. And I find that Claude sometimes jumps the gun with things, and so even when I do the full, and this is something that I can probably improve with the use of like hooks maybe, but the full seems to often skip some of these. So anyway, not perfect certainly. Other / commands, and then there's a list of the patches that I've generated. So some of these, I think the very first ones I generated were this rhythmic sampler, the Scala synth, the performance patch, test. I think I've renamed it performance test template. I need to update that. And the kick synth. And some of them required a lot of iteration to get working properly. And some of them worked very well right away. Like the kick synth came out pretty great on first try. I think I had to do some minor fixes. But like if we go over to the kick synth here, yeah, see it's got its own custom envelope display. It's got presets built in. Let's open it up. Oh, because I have this second monitor now, it's done weird stuff to my patch. But you can see here, let's make it bigger. So this, I had to do some finessing on the UI, but admittedly not that much. Like it struggled to get the panels nicely spaced, and I did, oh, interesting. I moved that from up there down to here, but it seems to have made it up there again. And you can see there's still a small issue there, so I'll just fix that now. But you can see it's kind of nice already. And turn up the output. Right, and there's different, you can oh yeah, so it's got no presets, but you can save the settings, right, if we play around with this. Got my scope, got my live dot scope, click level, sub level, noise, drive, all these things. And so that's presentation mode. And then under the hood is, you can see it's not the cleanest, but I did not manually edit this at all. So it's really not bad, all things considered. But like one thing it has trouble with is if there's a lot of, arguments to an object, it doesn't take into account the space required. I think I fixed that now, but like even with those all considered, you know, like that, or if it was how it was before, if making sure things are out of the way. You know, here there's another route. I'll just go like this, and then I'll do this trick that some people seem to love. I love, but some people don't like, is the Command Shift Y. That will just clean up all the cables. And so now, you know, now it's pretty easy to see what's going on. All the different parameters are being sent into and out of the presets to be saved, as well as the out to the envelope. And then this is really the kind of like heart of the patch, this. And this is where, and this is probably why it was successful first go, is that this Claude Code is pretty good with CodeBox, right? It's pretty good with this type of code. So we can see, you know, and it's also very good at organizing this code. So it's pretty easy to understand, right? It's used logical parameter names, set the min and max. You can see, yeah, trigger equals in1, trigger on, like it's very legible code because of the way it's named things. Often it will also include code comments, which I find very useful. I mean, this is a simple enough code box. It's only 76 lines. I mean, not even 76 lines really. And so, yeah, you can see that it, you know, how it's using all these different parameters to generate the sound, which is, you know, either more advanced or would be extremely time consuming if I tried to do this myself, and I probably would build it with you know, a number of different objects, and here it's done all very efficiently inside of a GenCode box. So that is one of the strengths. And then here we have the second GenCode box for the After Effects. Right, so let's see how large this one is. So the first one was about, let's say, about 70 lines of code. And then this Second one, oops, there we go. Make it a little larger. Second one is, yeah, similarly a little bit longer, and but this is doing the drive and EQ, right? So it has basic equalization algorithm here, and yeah, there's more EQ, and then I believe this at the bottom would be the drive. Yeah. So again, not, it's just a pretty straightforward implementation of well-known algorithms, but yeah, just done very efficiently inside of a Gen code box in a way that is yeah, much more efficient than how I would do it with, one poles and maybe external VSTs and all these other things that are less laser focused and efficient. So yeah, it could be, the organization of the patch could be better. Again, I think it's a little bit better now with the new changes, but yeah, kind of cool. Let's see how we're going here. So verify key objects in database. Okay, so now as part of the build, it's done its research into, what is it actually going to use to build this. And yeah, I'll write the gen expr engine and full patch structure into a single comprehensive build script. Yeah, so that's a Python script. The gen engine is built. Let me check for reference patches in the project and build the full patch. Great. Right, so yeah, it's completed this step essentially, and now build main patch, build parameter control network, build presentation mode, validate, finalize, and save patch. So yeah, we will see. In the meantime, why don't we look at some of the other ones? So here's one that it really struggled with. So this was the first or second patch that I generated, and I wanted to create like a multi-track sampler, I guess we call it. And it's now working quite nicely, but on first iteration, it was a real mess. So it understood from the get-go to use B patchers, right? So it's got these different slots. And so you have the individual slot max patches that from which that the B patchers are referring to. And then you can see under the hood, each one is kind of, each one is kind of complex. It's still pretty messy. I've been trying to get it to, like the last iteration I did on this was just asking it to tidy this up, and it's a little better, but it's still a mess. Before, this was like right on top of here, and there were no subpatchers for the initializations. This was all exposed, like all this was exposed. So it's a little better, but you can still see it's a mess. And the thing that I just doesn't seem to want to do is clean up the patch cords. So I'll just do that manually right now. But that's something to work on for me, is to get it to be better with the patch cords. The heart of the slot engine is this JavaScript file, which again, yeah, very well organized with comments. I should get it so it comments with the JavaScript really effectively, and not so much with the code box. So that's another sort of, maybe that's another thing I can improve in the system, is to get it to have meaningful comments in the code box. I find that very helpful. So yeah, that's sort of the heart of what it's doing, and it's got all sorts of controls and yada yada, and then so that's like the B patcher. And when I first created it, it could load a sample and play it back, but not much more than that. A lot of the controls weren't really working, and like the multi-slider like making changes in it didn't actually change the level of the sampler. But now it's all working. So I'll demo it a bit. I'll just load some blue noise into it, and there, you can hear that. So this won't affect it, but you can change the start position, right? You can override the BPM, slow it down, change the attack. do some EQ work on it. We get a high pass. Do some tape degradation on it. Boost it. Bring it down. I'll load a second sample in here. Unmute it. This one's very quiet. It'll be hard to hear. I can maybe make the volume a little bit more usable. Let's do this, and let's do this one at 90, this one at 60, oh, not 69, 60, and now I'm going to, that will synchronize the two right here. Maybe this, I should change the volume to logarithmic as well. Yeah, change the yeah, so kind of cool. So you can get it all going. You can also give it shapes, of course. Rhythmic patterns, change the number of steps. Yeah. So that's the rhythmic sampler. So this one took, I don't know, quite a bit of iteration to get it working how I wanted it to, and also realizing I was just realizing I should change how the volume control works a little bit. Other features that would be interesting to have. You can see the playheads are still glitchy. I don't know why they're still running. So there's still improvements to be made, and there already was a lot of iteration. But this was done with very minimal, just sort of like as a matter of course to test the system. This was done with very little manual fixing up. I did have to finesse some of the layout though, because it just kept being not quite right, and like to get the displays on the dials as they are, that was, well, now it's able to do it on its own, but it took me kind of manually doing it and saying like, have a look at what I did, and then trying to get the system to understand the z-axis to see what was in front, what was behind, and whatnot. Like the idea that sometimes I want an object to be on another object for UI reasons, I think is a difficult concept for the AI to understand. All right, let's close out. Let's see how we're doing here. All right, we're still working away. Let's see. So it says, so it's actually consuming many more tokens than this because it's running subagents and sometimes agent teams. And so, yeah, it's possible that it's eating up a decent amount of tokens. In fact, I'll have a look at my usage. So yeah, it's not too bad actually. So I'm on a max 20 plan. I'll probably reduce it because I'm not using it as intensely as I have been the past couple of months. But with the max 20 plan, it's used 9% of the current session, but only, I don't know, for the weekly limit, much less. So like of the whatever 5-hour sessions, it's now used 9%. So that might give you an idea of how much, how limited you are. So if you are on like the $20 plan, you could probably do this in one 5-hour session without running out of tokens, or maybe not quite. It might take 2 sessions. Yeah, 5 times or 10 times, or I forget what all the plans are. But the 20 times plan is very comfortable. I could use it. I could be doing like 4 of these at once, and it would be fine. And this one is a bit heavier than some of them because I asked it to do more thorough research. Yeah. And Cloud Code, it's only available for the paid accounts, so there is that limitation. Yeah, I'm just having a quick look. Yeah, so there's the max plan, the pro plan, I thought there was variations from, yeah, so the smaller max plan would probably still be plenty. The pro plan, you would, work on one patch at a time, and I think you would be okay, but you couldn't like be running a bunch of different instances and building multiple patches at once. Okay, great. We've done the next one, build gen. Okay, we're making a little progress. Could look at another one. So what was a more recent one that I generated? Tape wobble. Oh yeah, so this is a simple one. This is the most recent one I generated, and I just wanted to create something that would be fairly straightforward for it to do. But this was the one that I think on the first go, it was a total mess. And then I improved the system based on the problems it had, and then it generated it pretty much perfectly second time around. Yeah, that was this one for sure. So you see, this one I have not iterated on at all. So this is just the initial generation. And so, I haven't asked it to, put a panel behind it and make it look nice, and like adjusted the look of the font so that it's more legible and stuff like that. But you can see it's a pretty clean patch, and it's a tape wobble algorithm again, using a gen code box. Oh, and look, in here it's given it some comments as well. All right, it looks like our patch is done, but let me just have a quick look at this. Yeah, so it has, so it's added like labels for the different areas of the wobble for combined modulation, saturation, head bump EQ, drive wet mix, DC blocker. Yeah, great. So it's improved how it looks, and you can see, so this is the modulation signal, and we could change things about it to change that modulation signal, smooth it out, add more flutter to it. Great. Yeah, so that's the tape wobble. All right, but it looks like we're done. So let's see. I'm eager to see how this turned out. All right, let's read what it said first. Build complete. Here's what was generated. Time stretch at max patch, 62 objects, blah, blah, blah. 8 grain voices with hand windowing, signal routing, waveform display. Great. So I actually have to leave pretty soon. So let's open it up, and we'll see if it was a success or not. So time stretch generated. Time stretch as max patch. Okay, great. The UI actually looks pretty good. It's used these live dials, which I haven't seen it used before, which is kind of nice. Let's make it nice and big. All right. Density 4 voices, transient. All right, let's see if we have any errors in the Max console. Okay, we do. Use of undeclared identifier. SR, so sample rate. Okay, maybe it assumed what sample rate is and failed to compile patcher. All right, so we have some issues. Let me make sure that it's from this patch in case it's actually from an earlier thing. So I'll open this again. And okay, no, the errors, I guess the errors were from a different patch. So I'll have to go. I guess the errors were from a different patch. So see what that was. Oh. It looks like I'm being time stretched. Okay, that's another thing I don't want. I want to be able to switch. Oh my goodness. So how can I switch between the source? Oh. Is it still tracking me? It is. Okay, interesting. Oh, and it's got the transient detection there. I don't want it to be taking my live input. Okay. It's still, my audio is still flowing through, but it's no longer detecting my transients. And I also don't see a way to load. Oh, there it is. Load. Let's load this piano sample I have here from earlier. So it's playing without me prompting it to play, which is not great. And it's also, so let's set it to loop and play. It's very quiet. Pump it up there. gain doesn't seem to be movable. The pitch is. Alright, that works. Grain size. It's on adaptive, so that probably won't affect it. Quality. Okay, here's the stretch. Here's the important part. Adaptive extreme. Alright. It's going to be a long silence now because it's 4 times as long. There it is. Alright, I'm going to load a sound file that's a bit longer, or a bit louder. I have a sound file here of me singing, so maybe I'll use that. What did I call that? I called that just test audio or something like that. Stuttering test audio, there it is. Alright, so that's changing even though adaptive is turned on. It sounds pretty smooth. Like, it's not bad. Let's turn it up even more. Change it. Oh yeah, you can hear that. Interesting. The extreme, it's bouncing all around the buffer. I might not call that extreme. I might call that something else, but like start position jitter or something like that. Let's turn our quality up. See what happens then. Not sure if I hear a difference there. The jitter is not functioning properly. I don't know what SEN sensitivity. I'm not sure. That's probably a sensitivity for the attack detection. The gain is not movable. It's 1 or 0, so that has to be changed to a float. So there are some issues, but yeah, there are some issues insofar as it plays no matter what. Play toggle doesn't work, and there's a few other. All right, let me close it. There are a few other issues with the parameters there, but it's the algorithm in the code box seems to be working quite nicely actually, and so this is kind of where I'm at with the system in general, where it's very good at implementing in the code box, it's very good at implementing JavaScript, and then it's getting better as I work on it for everything else. Yeah, so the next step in this project would be I'll describe all the bugs, and then I will iterate on the max patch, and it should store into its memory the issues it's had so it doesn't have those issues in the future. But I find it's hard to tell how well that works, and so I'll probably also do a improvement on the system itself that focuses on the issues that I found with this creation of the patch. So sort of the more I use it, the more refined it becomes, ideally. And yeah, so that's it. I'm gonna end there, but I'm going to keep streaming as I build with this, in the hope that it'll help other people try to use it, maybe have some suggestions on how to improve it, and maybe sort of boil some of these live streams down into a more instructive video. So yes, goodbye.